All right, guys, we have 4.4 day 2 today. Simplifying radicals, rational exponents. Same as yesterday, really, just with more practice with it. So do the warm-up, pause the video, and then when you're done, resume the video. All right, so it says which of the following are the same as the third root of x to the fifth? So a definitely is the same thing. It's the third root of x and then all raised to the fifth. Those are the same things as we said yesterday. In the notes when we first introduced it. And then if you guys remember from ID, right, the index, which is 3, is the denominator, right? So that would also be the same thing as D, where it's x to the power of 5 divided by 3. So x to the 5/3, ID, index denominator. So A and D are both good. B and C, not so much. And then warm-ups 2 and 3, same thing. I want you to do these and then resume the video, pause the video, do these, and then resume the video when you're done. All right, so just again from yesterday's class, hopefully we kind of got this part, not from yesterday, obviously, but from the last class. So a 1/2 power is the same thing as a square root. So I'm just going to break it into the square root of 36x to the 12th. And so if you like to break those up into 2 square roots, you certainly could. And so the square root of 36 is 6. And then remember, the index is 2. So how many times does 2 go into 12? Well, that would be 6 times. So it would be x to the power of 6. So that would be this one. And then similarly, the last one, power of 1/3 is the same thing as the third root of each part. So I'm just going to break it up right away. Third root of 27, third root of x to the 15th, and third root of y to the 6th power. So the third root of 27 is 3, because 3 times 3 times 3 is 27. And then the other ones, we play the game where it's the index into the exponent. So 3 goes into 15 5 times, so it's x to the power of 5. And then the other one, 3 goes into 6 twice, so it's y to the power of 2. And that would be your answer for those. We keep going, just some more practice with this. These ones are going to look a little bit different, but it's more or less the same thing. So when we do these, right, we have a square root again. So power of 1/2 is a square root. So it's the square root of 72, square root of x to the 9th, and square root of y to the 5th. Now these ones you might look at and say, well, these don't go in cleanly. The square root of 72 it's really nothing perfect. So you just break it down the same way we always have. Square root of 72, I'm going to break it into the square root of 36 and the square root of 2, because 36 times 2 is 72, and the square root of 36 is 6. So we get 6 root 2. Now, this is an interesting one, right? The index is 2, which you can put it there if you want to. So how many times does 2 go into 9? Well, goes in 4 times cleanly, so it's x to the 4th. But then there's like a remainder, right? So there's a remainder of 1. So that remainder of 1 is like the 1x that can't come out of the radical, right? It's left over, so it just didn't come out cleanly. So that's what this one does. And then you're going to get the same thing with the y's, right? The index is 2. So how many times does 2 go into 5? Well, it goes in twice, so it's y to the power of 2. But then you have 1 left over, so y to the 1 left over. And as we spoke about last class, we just take all the things that are outside the radical, write them together. So 6x to the 4th y squared. And then all the things that are in the radical, we're going to write those together as one radical, so 2xy. And that's our answer for that one. And then we'll do a very similar problem here, where it's a 1/3 power, so that's a third root of each of these. And the third root of y to the 4th here. And it's really the exact same game. So the third root of 16 is not perfect. Remember, only 8 and 27 are really all that you need to know. So 8 does go into 16, so I'm going to break into the third root of 8 and then the third root of 2. And then the third root of 8 is 2, right? Because 2 times 2 times 2 is 8. So it's 2 and then third root 2. Now, when I go to the variables, it's a little bit different, right? I'm looking at how many times the index goes into the exponent. So 3 goes into 7 twice, so it's x squared, right? X times x that comes out. And then there's 1 left over, right? So that would be a cube root, right? Because if it's a cube root problem, it's always a cube root. And then with the y, same thing. 3 goes into 4 once, so y to the 1, and then there's 1 left over. There's like a remainder of 1, so that's going to stay in the radical. And so you see our final answer taking all the things that are outside and writing them together, would be 2x squared, y, x squared. And then my radicals are what's written together in a cube root, so 2xy. And that's it, right? So, all right, and then last part for this is group practice. So you can pause the video, work with the people around you. You can work individually if you want to, but just do these 4 questions, and then you can pause the video and then resume the video, and I'll just show you the work for those ones. But with 1 and 4, you can see it's already partly done. It's already written as a radical, whereas 2 and 3, you'd want to write it as a radical first and then go from there. But pause the video, do the 4 questions, and then resume it when you're done. All right, if you've finished with the 4, just going to show you guys the answers really, really quickly. So you can see this is all of the work and something. So if you want to pause the video, I'm not going to go through each one. I just did the first 2 examples. But if you want to pause the video, you certainly can and just check over your work. Number 4 is interesting just because there's a negative. But remember, if it's a cube root, it's not an imaginary number. A square root gives you imaginary. So if it's a cube root, you can just literally pull the negative out and keep it on the outside, because basically -1 times -1 times -1 is the same thing as, the cube root of -1. So like the negative can just come out with that one. So I'd say if you did those and you got a few of them right, you're in great shape. And then what I want you to do at this point is, you got some extra practice in the classwork. Pick a few of them, do that. You can do 5. I think you'd be in good shape. But at that point, if you feel like you're good, go ahead and start the homework. And then you might be able to get a good jump on that before class gets out. Thanks, guys.